All right, so we're going to talk about the basics of electric potential today, in case you guys don't remember what it is, or for all of my YouTube fans out there, in case you don't know what it is at all. So electric potential is something that we generally find from electric field, but it's more of like the equivalent of energy, right? It's so in electric field, we said the field is equal to force per charge, right? Potential, which we're going to use the symbol V for, is going to be energy. All right, energy out, because I already wrote E, per charge. Or, people usually write it as U over Q or work over charge. Would be other ways of doing it. So fundamentally, when we think of it, we need to think of it like energy. So some things we can know about it is we can know that potential is a scalar. And we know that its units should be, bad handwriting, should be joules over coulombs, right? And we're going to call that volts, or just V. So it's going to have the same symbol as the variable. I don't know if that makes you guys happy or upset, but that's how it is. Yeah. So how do we get from work or force to work or force energy? Well, the equation for doing that is work is equal to the integral of F dl, path integral. And technically this is a dot product because your path is a vector and so is your force. And work is a scalar. So it works out nice. And you get from A to B. So we're going to do something very, very similar here. We're going to use almost the exact same formula. And we're going to say that potential is equal to minus the path integral of E dl, or EDR, or whatever you call it. And once again, it's a dot product, which means, it's how we go from vectors to scalars. So if I have something like a constant field, so let's say there's a big, uniformly charged electric plate down here, and it's got field kind of going that way. Let's say it's negatively charged. I haven't done anything negatively charged in a while. The electric field will look like that. So if I said what's the difference in electric potential between this point and that point, we'll say that this is, 1 meter above the plane, and we'll say that's 2 meters, just to mix it up, between the two points. So we'll call this A and B. So what is the potential? Oh, you can't see half that. Sorry. What is the potential difference between those 2 points? Well, I just want to find my electric field. What's my electric field is constant, so let's say electric field is equal to some constant. We can say electric field is a function of x if we want, is equal to some constant, or y or z, I don't care. I guess let's go y because we're doing it vertically. So to get my potential, I'm going to say potential is minus the path integral from A to B, that's a B, of E naught dl. And we'll say E naught, I guess to be clear, we should say E naught is minus because downward in the y direction. So minus that, and we can put y here if we want, but we can just do the, leave the dot product. So we'll say, let's just do this. So then we'll say minus from A to B of minus E naught y hat dot dl. So what all these dot products are going to mean to us, it looks scary, and it looks fancy, and it looks, intimidating. But all it's really going to do is just say, hey, I don't care if we move this way or go in a loopy path, as long as we go from A to B, it's going to be the same thing. So that's all this dot product signs. It doesn't care about this motion or that motion. So we just care about this distance here, which we said over earlier was 2 meters. So now when integrating this, this is a constant. So I'm going to say v is equal to minus integral from A to B of E naught dy at this point, because we're just picking the y variable. That's what that dot product does for us. And I now can change my bounds of integration and say this is going to be minus 3 meters to 1 meter. E naught dy. So we're just going to get minus E naught times y. We're going to evaluate that from 3 to 1. So that's going to be minus E naught times 1 minus 3. So finally, we get minus E naught times negative 2. So our final answer is our potential. It is going to be 2 E naught. And if we want to do this in terms of variables without evaluating it, we would have gotten V equals E delta Y. All right. Let's call that good for today on this video. We'll come back next video and we'll talk about how to do it for a sphere. All right. See you on the next one, guys.